Hello and welcome back to Sheaff Math. In today's lesson, you're going to learn about simplifying radical expressions. Now, what exactly is a radical expression? Here is an example of one, the square root of 45. Now, it's the type of square root that if you put it into a calculator, it wouldn't give you a whole number answer. This is not a perfect square number. It would give you a big long decimal. Okay, so before we get into the method on how to simplify this, I want you to look at a few numbers that I'm putting down on the screen. Do you recognize these numbers? If you don't, you should. It should just jump right out at you. These are perfect square numbers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. Okay, you really need a good grasp of the perfect square multiplications. Now, you also need a good grasp of multiplications in general, so if you don't have that, you're going to have a tough time. Now, it wouldn't hurt to also have 11 times 11, 12 times 12, up to 15. You'd be surprised how many times those actually come up in math. And so I would suggest that you really become familiar with those so that you'll be more successful in this particular lesson. Now let's actually simplify a radical expression. Here's how it works. We have our square root of 45, and what you're trying to do is you're trying to think of, is there a perfect square that is a factor of 45, a number that goes into it or multiplies to make 45? And yes, 9 is a perfect square, and 9 times 5 makes 45. And so what we do is we separate them, 9 times 5 like that. And then what we're going to do is we're actually going to separate them into two different square roots. And so this is a perfectly okay thing to do. And now that we've separated them, square root 9 is actually 3. And so we can actually bring the 9 out, simplify it, and this is our simplified radical expression. Now let's try a few more examples. The first one is square root of 32. Now I'm trying to think of a perfect square that goes into these, and you want to, if possible, think about the highest perfect square that goes into them. Now I know 4 goes into 32, but I also know that 16 goes into 32. And so 16 times 2 makes 32. And so what I'm going to do is I'm going to separate those into separate square roots. And now I can simplify that square root 16, which is 4 square root 2. There's my answer. Square root 75. I know that 25 goes into it 3 times, and so I can simplify this with a 25. I'm going to separate those two into 2 square roots and simplify the square root 25, and I get 5 square root 3. Last example, 52. Now, what goes into 52? Does 4 go into 52? It does. Does 9? No. 16? No. 25? No. So I think it might be 4 is our only one. Yeah, 4 times 13. And so the square root of 4 times square root of 13, we separate those and we simplify that 4 and we get 2 square root 13. All right, now I do want to show you a little special circumstance. Remember that first one we just did, square root of 32? Let's say that you recognize that 4 goes into 32 8 times, okay? And this is what you did. You didn't realize or didn't think about that 16 was the highest square root. So you go ahead and you go about doing this and you separate them and then simplify it. But you always have to check to make sure that the number under that final square root cannot be simplified anymore. And 2 square root 8 can be simplified a little more. And so here's what we're going to do. We're just going to continue this. And we know that 4 times 2 makes 8. And so we can separate that 4 out, simplifying that square root 4. And now we get 2 times 2, which is 4 square root 2. And that's our answer. So if you didn't get the right square root at the beginning, you can always continue and simplify it more and more. All right, now sometimes you'll be asked to simplify an expression like this. 3 square root 28. Now, this happens quite a bit. 3 is out in front. Now let's look at the 28. Can that be simplified? Well, it sure can. 4 times 7. And so what we're going to do is we're going to separate the 4 and 7 and bring that 3 out front, and it's multiplying as well. We simplify the square root 4 to 2, and then multiply 3 times 2, which is 6 square root 7, our answer. Okay, here's another example. Now 18, I know that 9 goes into 18, so 9 times 2. I'm going to separate those out again, simplify that square root 9, and then multiply those two whole numbers in front, and I get 18 square root 2. All right, now here's a real tough one. Square root 294. Now trying to figure out what number goes into this is not easy. And so there are a couple of different ways that you can approach this, and I think I'm going to do another video on this, doing large radical expressions. But one method that I use, it's not what every teacher uses, but here's one that I try. What I try to do is I see if any perfect square can go into 294, so I start dividing it. I divide 294 by 4, and I realize it does not go in evenly, so that is not one of my numbers. So then I divide it by 9. Still, it doesn't go in evenly. By 16, doesn't go in evenly. 25, and I know this can take a long time. 36 doesn't go into it, but finally 49 goes into it 6 times. And so it's a long process, but this is what you have to do for these guys. They're not easy. So we put 49 times 6 inside, separate them, and then we simplify that square root 49 to 7. And there's our answer. All right, well, you just learned how to simplify radical expressions. I hope that you did well. If you need more help on this, I encourage you to rewatch the video and pause it if you want to really grasp the concept. Thank you for watching, and I'll see you next time.